Next, we want to figure out the mass in kilograms of 34 gallons of acetone, and we're given a conversion between gallons and liters. So in this problem, we also are given the density of acetone. 2 units lets us convert back and forth, in this case between grams and milliliters. Well, if we're looking for kilograms, we can get there if we get this grams. And to get grams, we could get there if we had milliliters. But our starting point is the known 34 gallons of acetone. Gallons is a measurement of volume. The density, it has its volume in milliliters. So we're going to have to turn our gallons into milliliters, but we can't do that in one step. Instead, we could turn our gallons into liters using the given conversion. 1 gallon is 3.785 liters. And now we want our volume in milliliters, so we're going to go using our table 2.2 knowledge. Milli is 10 to the negative third, so that goes on the opposite side as the prefix m. So we turn gallons into liters, then liters into milliliters, and now we can use this density conversion factor to turn our milliliters into grams. The grams is 0.786. The milliliters, again, notice there's no number there, but we know it's 1, or if you want to keep the sig figs consistent, you can write 1.00 milliliters. And now, finally, once we have grams, we can add the prefix kilo. Kilo is 1 times 10 to the positive third. So when we multiply all this out, in normal notation, it's 101.15034. Now if we count sig figs, 34 gallons has 2 sig figs. Gallon to liter conversion, 4 sig figs. Table 2.2, both of those are exact. And then the density, 0.786. has 3 sig figs. So the smallest number is 2 sig figs. In normal notation, this is difficult to write down because I can't just say, alright, I'm going to take the 0, look to the right of it. That's between 0 and 4, so I'm going to round it down. Common mistake would be just to write down 10. But that ignores the fact that the size of the number is a little over 100, not 10. So in normal notation, I could write this, but that only has 1 sig fig. So the way to avoid this is use scientific notation. If I was going to write this in scientific notation with the correct number, which is 2 sig figs, remember I have to go over 2 places this time. So I'm going to write 1.0 times 10 to the positive 2 kilograms. Here's another problem involving density. How many liters of gold could you buy if you had $15,000? You're given the density, and we have the current price of gold. So we have dimensional analysis problem again. Set the known equal to the unknown. The unknown is the easier of the two to find. How many liters? That tells you that the unknown, X liters. The known, in this case, is a little bit harder to find. There are a lot of things that we know. We know the density, we know the price of gold, and we know the amount of money we have. But if you remember, 2 units make something a conversion factor. 19.3 grams per cubic centimeter definitely has 2 units. That's a conversion factor. The price also has 2 units. It may be harder to see, but we have dollars and grams. So that's also a conversion factor. $15,000 on the other hand only has 1 unit. You almost never want to start with a conversion factor. You want to start with a unit that only has, the quantity that only has 1 unit. So the correct known is not the density. It's not the price of a gram of gold. It's how much money we have, which is $15,000. So your starting point should have just 1 unit. Now we have to convert the dollars, and we can use the price to turn dollars into grams. $45.22 gets you 1 gram of gold. And if you wanted to put extra zeros to match the sig figs, you could do that. Now we have the mass in grams, so we're going to be able to use the density to turn grams into cubic centimeters. And it's 19.3 grams for 1 cubic centimeter. So we've used all the information in the problem, but remember, use your formula sheet. When you get stuck, look on your formula sheet. If a conversion is on the formula sheet, I'm probably not going to write it on each question on the exam. You want to get used to working with your formula sheet as you're doing your homework problems, so you're aware of it when you get to the exam. So if you're aware of your formula sheet, you have a conversion there between cubic centimeters and milliliters. It's a 1-to-1 ratio. And then finally, now all we have to do is remove the prefix milli to get the unit we want, which is liters. So milli from table 2.2 is 10 to the negative third, so that goes on the opposite side. In normal notation, your calculator is going to be 0.0171871 liters. Now in terms of the sig figs, this is a little bit tricky. I'm going to assume that this $15,000, that's not just a period at the end of the sentence. I'm going to assume that's a decimal point, so that would be 5 sig figs. The price had 4 sig figs. The density had 3. Cubic centimeters to milliliters is exact, and milliliter to liter is exact. So the smallest number of sig figs is 3. I don't start counting at the 0. I have to start at the first non-zero digit, which is the 1, the 7, and the 1. Look to the right of it, that's an 8, so this is going to be rounded up to 0.0172, or in scientific notation, 1.72 times 10 to the negative 2 liters.